Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks problem of the day, and today's problem is brackets in matrix chain multiplication, and it is a hard level problem. So this problem is actually an extension of a very popular problem, and I'll tell you both of the problems. The original problem is actually you have been given these integer values, right? Now these values are not just some array values, they denote different matrices, right? And let us see how to denote. So this is going to be my first matrix, that is 1 cross 2. These are the dimensions of the first matrix. That means that the first matrix will have 1 row and 2 columns, and the second matrix is 2 comma 3. That is, the second matrix will have 2 rows and 3 columns. The third matrix is 3 cross 4, and the final matrix is 4 cross 5. So basically, if we have an array of size 5, there will be n minus 1 matrices, in this particular case 4 matrices, and that is what is denoted by A, B, C and D, right? This is the first information that has been given to us. Now we have to find a series of operations such that if you multiply all of these matrices to combine into a single matrix, the number of operations should be minimum. We'll look at it in a while, how the multiplication is done, how the number of operations are calculated, but this is what the overall question says. We have to understand this part for now. Now, finding this minimum number of operations is a very popular question. Like it is one of the few questions that we'll study when studying dynamic programming at first, and it is also known as matrix chain multiplication, right? It is exactly that particular question. Now, in this particular problem, the only extension was you had to find out the order visually, right? So normally what we do, we just find out the number of operations required, minimum number of operations required, right? Now we have to write down it in the form such that it is clearly visible that where the bracket should be placed or how the order should be done. So if you see this particular thing, you can see that the first bracket is here, so AB should be evaluated first. This will be your idea. Now when AB is evaluated, then this particular part will be evaluated and this particular part will be evaluated. So you have to write down all the different arrays or the matrices A, B, C and D and so on. Since the value of n is only up to 26, so you will only go up to 25 different matrices, and you don't have to worry about running out of the characters, right? So now we have to place the final brackets in such a way such that it denotes a valid combination, a valid series, as well as the number of operations required to multiply these matrices as minimum. This is what the whole task is. Now again, I have said the first part is a very popular problem, the second part is just an extension of this particular problem. So before diving deep into the problem, let us first understand how our matrices multiplied. So the very first rule is, let's say I have a matrix of 3 cross 2 and then I have a matrix of 2 cross 4, right? So 3 rows, 2 columns right here, and then 2 rows and 4 columns right here, right? So the very first rule that we have is, let's say this is R1 C1, this is R2 C2, that C1 should be equals to R2, right? If this is not equal, then the multiplication is not possible. So basically, if I have to show you, this two things should be equal, right? And that is ensured in this particular fashion because you see that this is R1 C1 right here, and this will be R1 C2. So this middle part will always be common in two matrices, and that is how this particular matrix or the series of matrices will always be present in a fashion such that we can multiply them, right? So this property will be always be ensured in the given input, that is for sure. Now the second property that we know is that the final matrix is of dimensions R1 cross C2, right? So the final matrix in this particular case will be 3 cross 4, right? This is the second important property that we need to know. The third thing is the total number of operations will be in this case equals to 3 into 2 into 4. What is this 3 into 2 into 4? 3 comes from here, this 2 comes from here, right? So you can take either this one or this one, both of them are the same, and this 4 comes from here, that is C2. Now how do we actually multiply this? Why is it coming out to be these number of operations only? We do, let's say the final matrix is going to be 3 cross 2, right? So let's say I create a 3, it's actually 3 cross 4, right? So this is 3 and this is 4, this is 3 cross 4. So there will be 3 rows and 4 columns. So let me just draw 3 rows and 4 columns, right? So what we generally do is, to calculate this particular item that is in row, let's say 1 and column 1, we will do this particular, we will take this particular row and this particular column, right? Let's say this is A, B, let me just write it with a permanent. So this is A, B, this is C, D, right? So the value will be A into C plus B into D, right? This is how we generally calculate. And if you do this for all these values, all these positions, the total number of operations you will eventually figure out is this much only, right? So that means if I know the dimensions of two different matrices, I will be able to identify whether I can multiply them or not by this particular rule, as well as what is going to be the total number of operations, right? I believe this much part is clear. This much knowledge of matrices about multiplication is necessary to solve this particular problem. If you don't know this, you will not be able to solve this particular problem at all, right? So now let us move forward. What I am going to do is I am going to store my answer in dp of ij, right? So this is going to be a double dimensional dp vector where I denotes the starting position and j denotes the ending position. We'll discuss what is the starting and the ending position, but let us just know that there are two values I and j, right? Now let us discuss in brief what are these starting and ending positions. Let me just copy this particular thing. So let's say we are here and I'm just going to paste this. Yep. So if I just make some spaces in between, yeah, so these are actually different positions. So this is 0, 1, 2, 3 and 4, right? Now what are these I and j going to note? So let's say I write I here and j here. My dp of ij is going to find me the best answer for this particular range. There are 3 elements in this particular range and hence the total number of matrices will be 2. I discussed this earlier. If there are n elements, the total number of matrices will be n minus 1, right? So for these 2 matrices, what is the best answer is going to be stored in my dp of ij, right? So we have figured out what is the purpose of dp of ij. Now let us discuss how are we going to find out the answer for dp of ij, right? For that we need to write the transition functions, right? So let's say dp of ij, we know that it is going to give us some answer. It is going to give us that answer by following a series of steps. We don't know what are those steps yet, but we can very well figure out what could have been the last step. So what are we going to do? Let's say I write the matrices. These are not the actual matrices, these are just some values. So that is why I am writing the actual matrices. Let's say these are different matrices A, B, C and D, right? So we know that dp of ij is going to store the answer for the number of operations for this whole range, right? But how did we reach at this particular range? Again, I said we could have gone through some series of operations. Now those operations could have been like this, that BCD was evaluated first and then multiplied with A, or it could have been like AB was evaluated first and then it was multiplied by CD, or it could have been like ABC was evaluated first and then it was multiplied by D. So my task is to figure out the best among all of these possibilities, right? So let me just say it again. I said that we are going to reach this final state where ABCD are one matrix by some number of operation or by a series of operations. We do not know what are those operations yet, but I can make my best possible guess for the last operation that was conducted, right? So it could have been a case that A was living separate and BCD was evaluated first together and then it was multiplied with A, right? The other way could have been that AB was evaluated first and then it was multiplied with CD, right? And it could have also been the way that ABC was evaluated first and it was multiplied by D. Which is the best possible solution for this particular input? As you can see that ABC is evaluated first and then it was later multiplied with D here, right, in the final answer, right? So we are just trying to figure out of all these multiple operations, so all of these are last possible operation, what could have been the last operation just before we combine all of this into one single unit, right? So we are making a possible guess on that particular last operation. So what are we going to do here is, let's say this is I and this is j. I'm going to start my k from here and it is going to go till this particular position. So k will be greater than I and less than j, right? So when k is here, this could have been a like separation point. So if my separation point is this one, what will be the final answer? You will see that the value will look something like this, that A was separate and then BCD was together, because 1 cross 2 is the dimensions of the first matrix and 2 cross 5 will be the dimensions of the second matrix. So if you carefully see that if I talk about BCD, right, BCD matrix, these three matrices are represented by these four values 2, 3, 4, 5, right. So now if I talk about the dimensions of B, it is going to be 2 cross 3, for C it is 3 cross 4, for D it is 4 cross 5. Now no matter in which order I multiply them, but when I finally multiply BCD together, the final matrix will be 2 cross 5, right. This is one important thing. So let me demonstrate it also. So let's say I multiply these two first, that will be 2 cross 4 and this is 4 cross 5. So these two multiplied will be 2 cross 5. Now let me go the other way around. So let's say I multiply these two first. So 3 cross 4 into 4 cross 5, it will be 3 cross 5, and then multiply these two, this will be 2 cross 5, right. So this is how you are seeing that inside this particular range, the final order will always be the first value and the last value, right. So this is the first value 2 and this is the last value 5. So basically what I am saying is, if I put a division here, or if I take the last multiplication at this particular point, my total number of operations will be 1 into 2 into 5, right. This is the last operation that I conducted, assuming that BCD was together and A was together, right. Now let me just move the value of K forward. So let me just erase all of this. So I'm just going to remove this, right. Now we have K at the next position. So J is still here and K is here. Now if I take this particular point as the middle point, you will see it is equivalent to putting a bracket like this, right. If I put a bracket here, what is going to be my answer? You see, this is going to be the first value, this is going to be the common value between those two matrices 3, and this is going to be final value. This is the total number of operations that will take place if I put a bracket here, right, for the last operation. Now once I figured out, let's say for each value of K I am going to figure out. So let me write it here. So what I am doing is, let's say I have three values I, J and K. For each value of I, J and K, what I am going to do, I am going to find out the current number of operations, that will be P of I into P of J into P of K, right. So I have figured out this part. Now this was the number of operations required in the last step, but you see I am dividing the whole problem into smaller problem. I have put down a bracket here, but I still don't know the answer. What is the answer for these two different parts? So I have to consider them as well, right. So what I'm now going to do is, I'm going to add dp of I k plus dp of kj, right. So this is my current answer, and my dp of ij is going to be minimum of dp of ij comma current, right. So you see, this problem might look difficult at first, and if you are watching this video for the very first time, if you are studying this problem for the first time, this might seem a little difficult, but eventually if you try to understand what it is, then it becomes very, very simple. It is also difficult due to the fact that there is a lot of concepts involved related to matrix multiplication. That is why it is also difficult. But now we are trying to simplify the problem. We had two ranges I and j, which is the starting and the ending point. We wanted to figure out a middle point k, where we can divide the whole matrix into two different parts, right. So you see, what we are doing is, let's say we had the whole range I and j. We didn't know how we arrived at this particular point. We didn't know how we combined all of this A, B, C, D together. If you multiply all the matrices, the final matrix will be A, B, C, D, right? But we don't know how did we arrive at this particular point. So what we are trying to do is, we are trying to put a separation at each of these points, right? Which is the possible points of separation, right? And let's say we put a separation here, then we are going to find out the answer for the left half and the answer for the right half, right? So let's say we put a separation here as well for the next value of k, when k comes here at this particular position. Now the separation will be like this. So what I do, I find the answer of dp of, let's say 0, 1, 2 and dp of 3, 3, right? So that is what is denoted by these 2 points, right? So basically I'm trying to point or figure out the point of separation, finding out the total answer contributed by it, and finding out the answer for the remaining separate points, right? So this is how you can find the minimum number of operations. This was the first part of the problem. Now we have to derive the original order in which the brackets were put. This part is relatively easier if you understand this particular part. Now we just have to maintain or save this minimum value, or the point where we got this particular minimum value. So what we can do is, instead of maintaining this dp only, I am going to maintain a dp of pair, right? So I am going to maintain dp of ij, instead of just being an integer, from integer I am going to make it a pair of integers, where the first part is going to store the minimum number of moves and the second part is going to store the value of k at which this particular minimum number of moves are possible, right? So let me just write it first here, because I need the number of operations here. If so, you see, if current is less than dp of ij dot first, then I am going to modify these values, right? So how do I do this? dp of ij dot first is equals to this is going to be equals to current, and dp of ij dot second is equals to k. So you see, for each ij, now I am going to store what is the point at which the division took place, right? So let me take this example. So abcd was there, right? So abcd was there, right? I am going to start my I and j, I will be equals to 0 and j will be equals to this last point, that is 4, right? I know that it is denoting this particular range. So first of all, I am going to put a bracket here, right? Now in the next step, what I am going to do is I am going to find the point of division with the help of dp of ij with these two values. In this case, I am going to find the point of division at this particular point. So this is index 3, right? So now when I find index 3, I am going to call two different parts, right? So first is going to be 0 to 3 and the second is going to be 3 to 3, right? So 3 to 3 is only one element, so we are just going to ignore it for now. Now in this part 0 to 3, what I am going to do is, first of all, since I value is 0 and j value is 3, I am going to put a bracket here like this, right? Now again I am going to find the best value of k. In this it is coming out to be k is equals to 2, right? And it will be stored in dpij dot second. I have already saved it here, right? So I can just figure out that it is the second position, that the middle point is going to be this particular element here. Now when I call the same helper function, I am going to call it from 0 to 2 and 2 to 2. 0 to 2 will be called here in this particular position, and then I again put a bracket here, right? So basically what I'm trying to do is I'm trying to figure out the middle point which I've already computed and saved, and I'm just trying to simulate the whole process, right? Now one more important warning, that this ij that I'm dealing here corresponds to this particular input matrix. It does not correspond to this particular matrix which we are trying to visualize. This is just for the sake of understanding. These values do not have anything to directly do with this particular value, right? We will have to figure out a way to map these values I to this one so that we can find our answer, right? We'll also discuss how we can do this, but I'm just giving you a warning before we do anything, right? Now we discuss what is going to be the idea behind this particular thing. Let us discuss how are we actually going to implement it. So the way I did it was, we are going to have n minus 1 matrices, right? So I created an array of n minus 1 plus n size, right? So let's say in this particular case, let's say we have 5 value of n was 5, so I want to create a size 9, right? So 4 plus 5. Let me just create an array of size 9. So let's say this is 1, 2, 3, 4, 5, 6, 7 and 8, right? So these are 9 spaces, and I'm going to put my elements right here, a, b, c and d, right? So now you see there are some positions before each element and some positions after each element. Now let us see what we can do with this. So this is 1, this is 2, this is 3, 4, 5, 6, 7 and 8, right? And the original values were 1, 2, 3, 4, 5, 1, 2, 3, 4 and 5, and these are at indexes 0, 1, 2, 3 and 4, right? Now as I told you, my I and j are going to traverse on this particular input matrix. So let me just draw it properly. My I and j are going to traverse on this particular input matrix, not this one which I am trying to visualize and which I am trying to form, right? So how are we going to map the values? So initially 0 and 4 are like this, 0 is here and 4 is here, right? So 0 is always representing, the starting point is always representing the first point or the row of some matrix, right? So this will be R1 and C1 like this, and this will be R2 and C2 and so on, right? So the starting point will always be denoting the row of some matrix, right? Let's say if this is the starting point, I want to figure out this particular position because I want to put a bracket in front of it, right? This is what we're trying to do. So if I want to put a bracket at 0, position 0, so I'm going to take this particular value I and add 1 to it. So this should actually be 2 into I. So let me demonstrate you what I'm trying to say. So this is the starting point for matrix 1. So let's say R1, this will be R2, this will be R3 and so on. When I am at index 2, I want to look at this particular index 4. Why is it so? Because for the third matrix, that is matrix C, I want to be at a position that is just before it. So if this is R3, then I should be pointing to this particular index 4. So how can I get it? The value of I here is 2, right? I can do 2 into I, that is in this particular case 2, right? So I'm going to get 4. So you actually don't need to do this plus 1. We are anyways going to get the same value, right? So what I'm trying to do here is for each matrix, I'm trying to figure out the position just before it, right? So let's say this was matrix 4. This is the starting of matrix 4. I want to figure out this particular position 6 because this is just before the starting of matrix 4. So what I can do is I can take this particular I starting point and multiply it with 2. So that is 2 into I. In this particular case, it is 4. Now I also want to figure out a position just after the ending matrix. So initially the value of j is equals to 4, right? That is denoting the ending of this particular point. So how can I find out the value of 8? I can multiply it by 2, right? So if I multiply it by 2, I'm just going to get a position just after it. Similarly, for the third matrix, this is the ending point of the third matrix. This is the starting point of the third matrix. This is the ending point of the third matrix. If I want to find out a position just after it, I can take this particular index and multiply it with 2. So I'm going to get this particular ending index, right? So let us just once try to simulate all of this. So let me erase all of this for now. So initially we have 1, 2, 3, 4 and 5. Now what I'm going to do, this is the initial I, this is the initial j, right? So this is I, this is I and j. As soon as I receive I and j, I want to put a bracket once in front of the frontmost element and once in end of the lastmost element. So how do I figure this out? I am going to multiply both of the indexes by 2. So this is 0 index 1, 2, 3 and 4. So 0 times 2 is 0. So I am going to put an opening bracket here, and 4 times 2 is 8. So I am going to put a closing bracket here. Similarly, in the next step, the value of k, in this particular step, the value of k will be 3. So if k is 3, I am going to call 0, 3 and 3, 3. Since 3, 3 is only one element, I am just going to ignore this. Let us focus on 0, 3. So 0, 3 will be here. So j is now here. Again, I want to put an opening bracket at twice of I. So that is here. And I am going to put a closing bracket at twice of j. So that is 3 to the 6 right here. Similarly, again the value of k is equals to 2 here, right? So this value of k will be coming from our dp, which we have already calculated. So again, we are going to call our helper function on 0, 2 and 2, 3. So since this is only one element, we just want to ignore this particular part. So what we are going to do, we are just going to move this j forward. Since j is at 2 now, I am going to put an opening bracket at 0, that is 0 into 2 and 2 into 2, 4. So a bracket at this particular position. Again, the value of k will be equals to 1 here. So my helper will be called on 0, 1 now and 1, 2. 1, 2 is only this last element. So we are going to ignore this. Again, 0, 1 is only one element. So we are going to ignore this. So you see, we will have this particular vector of strings where we have all the characters. So we can just write it into our answer string. So it will be 3 opening brackets, then A, then empty, then B, then closing, then C, then closing, then D, then closing, right? So this is how you can figure out your final answer. I know this was a little bit complex, and the last part is particularly like not very easy at all, simply because these values that we are given in the input, these values, right, are different from how we can write our matrices, right? So these are two different things that you need to consider. So that was it for this particular video. Now let me just quickly explain the code. I don't want this video to be too long. So what I'm doing is, first of all, I'm creating a double dimensional vector, and the input data type is long comma integer. So long is going to denote the number of operation and integer is going to denote the dividing point, right? I've initialized all of them with 10 to the power 18 and -1. Now you see that if I take I in I plus 1, that is I comma I or I comma I plus 1. If there are only one or two values, that basically means these are only going to represent only one matrix. To represent two different matrices, we need at least three values, right? So if there are only two or a single matrix, I am going to set their answer as 0, right? Because I don't need to worry about them. I need to only multiply those matrices which have size at least, input size at least 3, so that there can be at least two matrices. Now you can ignore these for loops for now. Let us just focus on this middle part first. So what I'm basically doing is P of I, P of j into P of k. This is the number of operations. If I take all the matrices in the range I to j and I take the division point as k, right? Now if I do this, this will be the number of operations, and then I'll have to perform this particular part. That is, I'm finding out the answer into two different halves. That is from I to k and from k to j. I perform a division from like at point k for the range I to j, right? If I perform a division at point k, I also need to compute the answer for I to k and from k to j. This is what I'm adding here, right? Now if current, that is the number of operations, is less than dp of ij dot first, I'm going to update dp of ij dot first, and I'm going to update the optimal division point, that is k, right? Once I figure out all of this out, now what I have to do is I just have to basically simulate the whole process. Before that, let me talk about this particular for loop. You see that these two for loops are in increasing order and this one is in decreasing order. So how will this help us? So let's say this is the back of the array. This is the back of the array and I am going from here to here. So let's say I am at this particular point, I calculate all of this. Then I am at this particular point and then I calculate all of this. Why is this important? Because I need a point k and I already need to know the answer from this point to this point. This is the only possible way. If I perform the iterations in this particular form, this is the only possible way in which I will know if I am at I comma j. With this way only I'll be able to know the answer from I comma k and k comma j, right? This is the only way in which you will know both of these answers, right? Otherwise you will miss either one of these, right? So what you have to basically do is you just have to take your I for loop from reverse to back and your j for loop from front to back, right? So this is the only way you will be able to maintain or you will be able to calculate these two states before calculating I comma j, right? So this is just one thing that you need to take care of. How? Let me just explain this part also, although it is not very difficult, but just for the sake of explaining. So what I'm trying to do is I'm trying to go from reverse to front. So if I do this, this I comma k will be calculated in correct order. Now the j for loop is going from front to reverse and that will help me to calculate this k comma j correctly, right? Only when these two values are calculated I can calculate I comma j, right? Otherwise I cannot calculate I comma j, right? Because ij is depending upon ik and kj. Let's say we have calculated all of these things, then we create our final result array of size n plus n minus 1. All of them are initialized with empty string. Now I start from index 1 and I am just incrementing in I by 2 each time, and for each of these positions I am placing the characters A, B, C, D and so on. So you see I have initialized in with A and it is just incrementing by 1 while the index are incrementing by 2. So it is going to put A, B, C, D and so on in the result vector by leaving 1 spaces in between. Now I have my helper function. You see I call my helper function on 0 comma n minus 1, that is the initial I and j. Now if j minus I is less than 2, if it is true, that means there will be less than 2 matrices in this particular range. That is why I just return from here, because there are no matrices to multiply. Then I can find the starting and ending position. You see that this plus 1 is not actually required. We can just remove this. Similarly for this. And now I can figure out what are the optimal positions. So I can just remove all of this and just write j into 2 as well. I believe it should work, right? So I into 2 is the starting position and j into 2 is the ending position. I put a opening bracket at the starting position and a closing bracket at the ending position. Now I just call my helper of I comma dp of ij second and dp of ij second comma j helper on the second part. So you see I'm just trying to simulate the whole process. I'm putting brackets and just calling the helper function on those two different halves. At the end I can just initialize my answer with an empty string, and for going through all the values in the result vector, I'm just going to add it into my answer and then just return my answer. So how do I escape this particular? Yeah. So let me just try to submit this and see whether this works or not. So you see this passes all the test cases and this solution is absolutely correct. I hope that you guys were able to understand the solution. I know that this problem was a little bit long, and it's hard in terms of implementation because you'll have to think a lot in this particular part as well. So that is it for this particular video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.